All right, in this chapter, in this section, I did it again. In this section, we're going to talk about rates of change. So specifically the average rate of change. So, you know, if you're driving your car, the speedometer is saying something different at different times, unless you're on cruise control, right? The speedometer, your rate of change of position, your velocity is always moving, but you can also calculate your average velocity, right? If you want to know your average speed going from point A to point B, you just say, okay, how far did I go? Divide that by how long did it take me? And that's what we're doing right here. Okay, so definition. The average rate of change, and I hope you enjoy seeing it right now. You got kind of 3 times because I'm never going to write it again. All right, I'm always going to abbreviate that average rate of change like so, with a little o. The average rate of change is given by this formula. And it's got a couple different iterations. So again, it's just how far did we go for velocity, average speed. How far did we go divided by how long did it take us to get there. But in general, it's the change in output divided by the change in input. Now this should maybe look a little similar to something you've seen in an earlier math class, but let's rephrase this in a couple different ways. The change in output a lot of times is called delta Y. All right. Delta often means, well, delta, this is capital delta. Delta certainly means something different in 2022 when I'm writing this, more in 2021, I guess, but delta means change. Okay, divided by delta X, change in output divided by change in input. And we can write this another way as well. Change in output is maybe the second Y value minus the first Y value divided by the second X value divided by the first out. Okay, this is looking really familiar right here, right? You've seen this before. I know you've seen this before. This is slope. The average rate of change is just the slope of a function. If anyone's going into calculus, that's going to be huge. Okay, and if you're not, that's fine too. And then finally, we have one more formula. All of these are different good ways of thinking about average rate of change, but this last one is maybe the most common, right? The Y value, this Y sub 2, Y2, is just the function value at the second X value, okay? So evaluate the function at that X value minus Y1 divided by X2 minus X1. This is the formula that we're usually very frequently going to be using. So all of these are correct, but this last one's the most commonly used. So let's explore this a little bit. It's the slope. What that kind of means is that if we're looking at some function, say we're looking at some function, maybe it looks like this. Oh, first I mentioned delta, now I'm looking at an exponential graph. Whew, got COVID on the mind today. So if we're looking at the average rate of change between these 2 points, that average rate of change is just going to be the slope between these 2 points. What's the slope between these 2 points? That's what's known as the slope of a secant line. All right, the slope of a secant line is what it's called. It's the average rate of change. That's a kind of little bonus thing, because eventually I get excited talking about calculus, but it's very closely related to calculus. Because as we move these closer together, the average rate of change gets closer and closer, and it eventually approaches something we call a tangent line. That's not really that necessary here. What's necessary here is this formula. Can you find the average rate of change? Let's do some examples. This is just little fun, free bonus information, okay? A little free mathematics for you to get excited about. Example 1. The table below shows the average gas price. That's not how you spell average. Average gas price given in dollars per gallon. Dollars per gallon in the US in year Y. So here's the year. Here's the cost of a gallon of gas. Whoa, that was an interesting line. We've got a little table here. So in 2005, cost of gas was $2.31 a gallon. 2006, $2.62. In 2007, is about $2.84. And in 2008, a very special year, was $3.30. Okay? If you don't really remember what happened in 2008, I guess maybe it's in a history book now. Okay, so the question is, find the average rate of change of the cost of gas between 2006 and 2008. So we can use any formula we want. But be a little careful with this Y one, the Y formula, because here Y is our independent variable. Here Y is our input, which happens sometimes when we talk about time. But the important thing, right, is that it's the function value at the second point minus the function value at the first point. It's the change in outputs divided by the change in inputs. That's probably the easiest formula to use here, but they all work. Change in outputs divided by the change in inputs. In this case, the average rate of change, what was the output in 2008? $3.30. Minus the output in 2006. $2.62. That's the change in output, is the difference in these, in the function value. Function value is output. Let's divide by the change in the inputs. What's the input? The inputs are the year. So between 2008, well, that's just the difference between these 2 years. Okay? A couple of different ways you could approach this problem. This is one of them. And now we have to simplify the numerator. You subtract that out, that's going to be 68 cents. I think. And what's the differences in the years? 2. Divide 68 cents by 2, and we're going to get 34 cents. Now be very careful here. We're going to need the units here. And the units are going to be determined by what's up here. Notice that on top, right, 330. That's the cost per gallon. On the bottom, that's the year. So our units are right here. Dollars divided by years. The average rate of change was 34 cents per year for a gallon of gas. That's the average rate of change. So it didn't actually increase by 34 cents every year, but on average it did. So even though it only increased by 22 cents here, and then by 46 cents here, on average, it was increasing by 34 cents every year. And again, be very careful with the units. The units are always going to be the units on the top, divided by the units on the bottom. Top is price, cost. Bottom is year. So, dollars per year, like so. Let's do one more example problem here with 2 parts. So I guess it's kind of 2 examples. Let's do example number 2. Find the average rate of change on these 2 intervals. First interval, -1 to positive 2. And we're looking at the function y equals x squared. Whoa, it was almost straight. Y equals x squared. Let's go 1, 2, 3, 4. I don't want to bring back my graph paper. Our function is going to look like this. And again, this is one of our toolkit functions. One of the functions that it would behoove you, it would benefit you to be familiar with. So the average rate of change on this interval, let's use the formula. The formula said the average rate of change is f of x2 minus f of x1 divided by x2 minus x1. So let's figure out what all this stuff is, because this is a lot of stuff here, right? So this is x2, that's the second x value. x1, that's the first x value. So f of x2, let's just start by doing that. Replace all the x1s with -1. Replace all the x2s with 2s. This becomes f of x2. This just becomes this. They're the same thing. Minus f of x1 divided by x2 minus x1. Be a little careful here, right? We're subtracting x1, and x1's already negative. Again, all we're doing right here is plugging these in. Okay. This becomes this, because x2 is equal to 2, and so on. All right, next we have to figure out, let's go off to the side, what is f of 2? What is f of -1? We'll use the graph. F of 2 says, what is the function value when x is 2? So x equals 2 is here. What's the function value? It's the y coordinate when x is 2. This y coordinate is equal to 4. What's the function value when x is -1? That's this point. When x is -1, the y value is +1. So again, let's go back and replace these. F of 2 is equal to 4, so replace f of 2 with 4. F of 2 becomes 4. F of -1 becomes +1. The denominator is 2 minus a -1. The negatives cancel. It becomes 2 plus 1. Let's just simplify it. We get 3 over 3. This is the average rate of change. And there's no units here because it's not an application. And that's our final answer for part A. And then we have that little tease for anyone who's curious about calculus. Between when x is -1, when x is +2, the slope of this line is our average rate of change. Okay? Because how is this thing actually changing, right? Well, it's going down. Yellow is a terrible choice here. I can't see yellow at all. Right? It's going down and then it's going up. But on average, this is how it's changing. Okay? That's the secant line right there, that yellow one. I'm going to do part B as well. Find the average on the interval from -1 to 1. And this is very similar. Our first x value is -1. Our second x value is +1. Well, we already know what f of -1 is. Well, hold on. Slow down, Jason. Average rate of change, just like before, is the same exact function. But now it becomes f of +1 minus f of -1 divided by +1 minus -1. F of -1 is the same as before, but we do need to figure out what f of +1 is. When x is +1, y is also +1. So we'll replace that. And we're going to get f of 1 is equal to 1. F of -1 is also equal to 1. 1 minus -1 is 1 plus 1. Got a lot of 1s. This is 0 divided by 2. The average rate of change on this interval is 0. Because if we're just looking between +1 and -1, how is it changing? Well, between x equals +1 and -1, it's not changing at all. So it goes down and then it goes up, but on average, it's not changing. The slope of this secant line is 0. Good luck, and let me know if you have any questions.